class, in this video, we're going to be looking at the arrangement of the periodic table and lastly looking at groups and periods. The learning intention of this video is for us to explore how elements are arranged in the modern periodic table and for us to learn what information is given to us by the group number or the period number of an element. So firstly, how are elements arranged in the periodic table? The periodic table is organized in a very specific way. In the periodic table, elements are organized by increasing atomic number. Furthermore, elements are also organized and grouped based on their chemical properties. So elements with very similar chemical properties will sit very closely together on the periodic table. They're also grouped based on the electron configuration as well as the number of occupied electron shells. Many students often believe that the elements in the periodic table are organized by atomic mass. This does appear to be the trend for most of the cases, but there are some exceptions to this rule. So I'm going to show you these exceptions over here. So let's actually take this over here as the example. If you examine these two elements, one's cobalt, the other one's nickel. Now nickel is found on the right of cobalt, and if you look at the mass number or the atomic mass of nickel, it's actually got a smaller mass as opposed to cobalt. As a result, this proves that the periodic table organizes elements by atomic number rather than the atomic mass. What I'm going to talk about next is what are groups and what are periods. So we define periods as the horizontal rows in the periodic table and we number them from top to bottom. In contrast, we refer to groups as these vertical columns in the periodic table and we number groups on the periodic table from left to right. If you examine this slide, you can clearly see that the periodic table contains 18 groups or 18 columns. However, when I get my students to learn how to number the group numbers on a periodic table, I often get my students to ignore all the elements in the center because these elements, firstly, behave very differently from all the other main group elements. So that's reason number one. So if we do that, therefore we number the periodic table as 1, 2, 3, 4, 5, 6, 7, 8, like so. Another reason why I'm getting you to follow this particular format is because for the very first 20 elements in the periodic table, the number of valence electrons varies between the number 1 all the way to number 8. As a result of this, it's better to number the group numbers from 1 to 8 rather than from 1 to 18 because you can't really have 18 electrons in the last shell for the very first 20 elements, which is what we're primarily concerned with. The next thing I want to talk about is extracting information based on the group number or period number that the element is found in. So for the group number, elements that belong in the exact same group always have the exact same number of valence electrons. So elements found in the same column will have the same number of outer shell electrons. Furthermore, the group number can also be used to predict the ionic charge of an atom. So if you look on the periodic table down on the right hand side, you can see that we can predict the ionic charge of an element relatively easily. Notice that any elements that's found in the very first group or the very first column will always have a positive 1 charge if it forms an ion. Any element that is found in group 15 or in group 5, that will have an ionic charge of -3. So what I do recommend is that it might be useful if you included this particular information over here on your periodic table so that you can easily obtain what is the ionic charge of certain elements. Now this is also summarized by these 2 dot points over here. So I've said any elements found in group 1 to 3. So again, notice that I'm labeling this as group 3 rather than group 13 will have a positive charge. Whereas any elements found in group 5, so in this one over here, 2, 7, will have a negative charge. On this slide, I'd like to further reiterate that elements that belong in the exact same group will always have the exact same number of outer shell electrons. So if you look on this example over here, I've got hydrogen, lithium, sodium, and all these elements are found in group 1. Because they're found in group 1, you can clearly see that they will also have the same number of outer shell electrons, which is 1 in this case. Let's also look at another group to see whether it follows this trend. In this example over here, I've got the elements fluorine, chlorine, bromine, and iodine, and all of these elements are found in group 7 or group 17, however you like to label it. In these examples over here, notice that all of these elements, they contain 7 valence electrons on their outer shell. Now that we've looked at the group numbers, let's look at what information we can get from the period number. The period number that the element belongs to indicates the number of occupied electron shells. So if you look at the example down below, both carbon and oxygen are found in period 2. So they're found in row 2 on the periodic table. Because they are both found in row 2, this means that they should have 2 occupied electron shells, and this is supported by these illustrations of the atomic structure for both of these elements. This slide over here shows you a quick summary of groups and periods and shows you what kind of information can you get from the group number and the period number. I would now like you to have a go with answering this question. When you're answering this question, please do not refer to the periodic table because I'm going to get you to justify your reasoning. So identify which of the following elements down below are found in the exact same group and the exact same period. Give yourself 2 minutes and we'll go through the answers together. So if you answered this question correctly, you should have answered that lithium and sodium are found in the exact same group, and the reason why we know that is because they contain the same number of outer shell electrons. So both lithium and sodium have 1 electron on its outer shell. Elements that are found in the same period should therefore have the same number of occupied electron shells. In this example, lithium, oxygen, fluorine, and neon all are found in the exact same period because they contain 2 occupied electron shells. Have a go with answering a few more questions. This question reads, which elements have similar chemical properties? The answer to this is all elements that are found in the exact same vertical column, so elements found in the exact same group. This question wants you to identify 2 elements from this list over here that have similar chemical properties. We know that elements that belong in the exact same group will have similar properties, so as a result, the answer to this would be nitrogen and phosphorus. This question asks you, what does the period number tell you? We know that the period number tells us the number of occupied electron shells. And finally, this question is asking, what does the group number tell us? The group number tells us how many electrons are present on the very last shell. This is the end of the video. Thank you for watching, and I'll see you guys again in the next one. Bye.